June 6, 1944, 0630 hours, Omaha Beach, Normandy. The ramps drop, and American infantry surge into a maelstrom of steel and fire. But among the chaos, the screaming wounded, the bodies rolling in the surf, the German MG-42s ripping through flesh. At 1,200 rounds per minute, something else is happening that no history book will ever quite capture correctly. High above the carnage, Cliff P-47 Thunderbolts painted with white invasion stripes are tearing apart German strongpoints with unprecedented precision. Their pilots, guided by ground controllers speaking through crystal-clear FM radios that allow real-time coordination impossible for any other army on Earth. U.S. Army Signal Corps Technical Report. July 9. On the eastern flank, British troops are pushing inland under the same air umbrella, benefiting from the same American-designed -300 Seychelles rupees backpack radios that make fluid combined arms warfare possible. Within hours, Churchill will cable Roosevelt with gratitude. Within decades, the radios will be remembered as British ingenuity. The theft has already begun. This is not a story of military failure. This is a story of something far more insidious, the systematic erasure and reattribution of American technological, industrial, and tactical breakthroughs that made Allied victory possible. From the beaches of Normandy to the forests of the Ardennes, from the North Atlantic convoy routes to the skies over the Ruhr Valley, American innovations born in the labs of Bell Telephone, the assembly lines of Detroit, the testing grounds of Aberdeen Proving Ground were saving Allied lives and breaking Axis armies. Yet in the decades that followed, these achievements would be quietly reassigned, their origins obscured, their creators forgotten, while other Allied nations accepted to credit with polite smiles and silent complicity. The year is 1940, and Britain stands alone. The Luftwaffe hammers London nightly. U-boats strangle supply lines. The Soviet Union is still signing non-aggression pacts with Hitler. France has fallen in 6 weeks, exposing the catastrophic failure of French military doctrine and the myth of the Maginot Line. Into this darkness, America is not yet a combatant, but it is already the arsenal. President Roosevelt's Arsenal of Democracy speech in December 1940 formalizes what American engineers and industrialists have already begun: the largest technology transfer and production sharing program in human history. Boeing B-17 flying fortresses, still experimental, are being studied by Royal Air Force technical teams. The Norden bombs hit America's most classified weapon system. More secret than the Manhattan Project in 1940 is being shared with Britain. Under strict security protocols that will be violated within months. FBI Security Review. Norden Case File, 1943. Lend-Lease will eventually deliver $31.4 billion in aid to Britain alone, over $600 billion in today's currency, including 14,795 aircraft, 27,000 tanks, and technological blueprints that British industry could never have developed independently. US Lend-Lease Administration Final Report, 1946. But the gift comes with an unspoken cost: memory. As American-designed consolidated B-24 Liberators roll off British assembly lines under license, they become British bombers in popular imagination. As American radar technology developed by the Radiation Laboratory at MIT and refined by Bell Labs engineers is integrated into British air defense networks, the myth of purely British radar supremacy hardens into historical fact. The cavity magnetron, often credited as a British invention, was indeed British in origin, but its mass production, refinement, and integration into shipboard and airborne systems, capable of detecting submarine periscopes at night. It was American engineering, funded by American dollars, built by American workers at companies like Raytheon and Western Electric Mite Radiation Laboratory, Technical Series, Volume 12, 1947. The British provided the seed, America provided the forests. By 1943, the imbalance is staggering. American factories are producing more war materiel than all other Allied nations combined. The Fort Willow Run plant is completing one B-24 Liberator bomber every 63 minutes. Ford Motor Company production records. 1943. Chrysler's Detroit tank arsenal is churning out M4 Sherman tanks at a rate the Germans can only describe as impossible in captured Wehrmacht logistics reports. Bundesarchiv, Panzer Production Analysis, February 1944. Yet the Sherman will be mocked in postwar British memoirs as a death trap. Its success is attributed to overwhelming numbers, rather than the brilliant industrial engineering that made those numbers possible. The proximity fuser miniaturized radar system inside. Every artillery shell that detonates near enemy aircraft without needing a direct hit, increasing anti-aircraft lethality by a factor of 5, is developed entirely by American scientists at the Applied Physics Laboratory and remains classified until 1945, U.S. Navy Bureau of Ordnance Report, 1944. It saves thousands of Allied lives. Few will remember it was American. The pattern is set. The weapons flow east and west. The credit flows back, diluted and redistributed, and buried in classified after-action reports, in the technical manuals. Stamped secret and archived in basement vaults lies the evidence of what really happened. A singular explosion of American innovation that rewrote the rules of modern warfare and won a global conflict, only to be parceled out and repainted in the colors of other flags. The question is not whether America's achievements were stolen. The question is how and why the theft was allowed to stand unchallenged for 80 years. The secret was not a single weapon. It was a system of vast, interlocking web of technologies, doctrines, and industrial processes that transformed warfare from a contest of courage into a contest of engineering precision. And at its heart was something so mundane, so utterly unremarkable to civilian eyes, that it would never make the history books. The handheld FM radio, April 17, 1943, Kasserine Pass, Tunisia. American forces, bloodied but not broken after their humiliating defeat 2 months prior, are now pushing against the Afrika Korps with a coordination that leaves German commanders baffled. Every American infantry company carries -536 Seychelles rupees handy-talkie radios, 5-pound units with a 1-mile range, allowing squad leaders to communicate instantly with platoon commanders. Technical Manual, TM11 to 242, 1943. Every battalion has multiple -300 Seychelles rupees backpack radios with a 3-mile range, linking companies to artillery batteries in real time. When American spotter planes identified German tank concentrations, the information travels from cockpit to artillery commander in under 90 seconds. German response time, dependent on motorcycle couriers and vulnerable telephone lines, averages 11 minutes. U.S. Army, the Second Corps after-action report, April 1943. In mobile desert warfare, those 10 minutes are the difference between a successful ambush and a routed column. The Germans are fighting a 1940 war with 1918 communication systems. The Americans are fighting a 1943 war with technology that won't become standard in European armies until the 1950s. The -300 Seychelles rupees, designed by Motorola engineer Daniel Noble and produced by Galvan Manufacturing, was not merely an incremental improvement over existing radios. It was a paradigm shift. IEEE Transactions on Military Electronics, Volume 8, 1964. Frequency modulation, pioneered by Edwin Armstrong in the 1930s and refined for military use by the U.S. Army Signal Corps, eliminated the static and interference that plagued amplitude modulation radios. German commanders, intercepting American transmissions, reported dramatized, composite, unnatural clarity, as if speaking face. Even in electrical storms and artillery barrages, British forces, still reliant on the bulky and unreliable wireless set-no, began requisitioning American radios in such quantities that by late 1943, entire British armoured divisions were equipped with SCR 508 and SCR 528 tank radio sets. American designs, American production, installed by American technicians. British Army Equipment Reports, 1943-44. Post-war British armour doctrine would credit superior Commonwealth communications, without mentioning the stars and stripes stamped on every circuit board. But radio was only the beginning. Beneath the waves of the North Atlantic, another American breakthrough was rewriting naval warfare. The Mark 14 torpedo, infamous for its failures in 1942, had been systematically debugged by the Naval Torpedo Station at Newport, Rhode Island, and by mid-1943 was the most lethal submarine weapon in any Navy Bureau of Ordnance technical report. September 1943, the Mark 14's magnetic influence exploder designed to detonate beneath a ship's keel, breaking its spine, was now functioning flawlessly after American engineers corrected depth. mechanisms and firing pin designs that German and Japanese torpedoes would never match. U.S. submarines in the Pacific were sinking Japanese merchant tonnage at a rate of 300,000 tons per month by late 1943, strangling Japan's war economy. U.S. Strategic Bombing Survey, Pacific War Report, 1946. In the Atlantic, American-designed depth charges with new torpex, explosive fillings, 50% more powerful than British Amatex, were killing U-boats at unprecedented rates. The Type 7 U-boat, once the apex predator of the seas, now had a 75% chance of never returning from patrol. German Naval Archives, U-Boat Command War Diary, 1943-44. British anti-submarine forces used American depth charges, American Sanoboys, American Lee lights for night attacks. The victory over the U-boat would be remembered as a British triumph of the Battle of the Atlantic, with minimal acknowledgement that American technology provided the weapons and American shipyards provided 2,710 Liberty ships to replace losses faster than Germany could sink them. U.S. Maritime Commission Final Report, 1946. Then there was the P-51. Mustang, arguably the single most important aircraft of the European Air War, designed by North American Aviation in 1940. The P-51 was initially dismissed by the U.S. Army Air Forces as underpowered. The British Royal Air Force, desperate for fighters, ordered 320 aircraft and discovered its potential. RAF Aircraft Evaluation Report, 1941. But it was American engineers at Rolls-Royce's American partner, Packard Motor Company, who adapted the British Merlin engine for mass production, and American aerodynamicists who refined the laminar flow wing design that gave the Mustang its extraordinary range, 1,650 miles, with drop tanks, enough to escort bombers to Berlin and back. North American Aviation Technical Specifications, P-51D, 1944. By 1944, Mustangs were destroying the Luftwaffe in a calculated war of attrition. American pilots shot down German aircraft at a kill ratio exceeding 3 to, while German pilot training programs collapsed under fuel shortages and relentless pressure. Luftwaffe loss reports, 1944. Post-war British historians would emphasize the Merlin-powered Mustang as if the engine were the achievement, conveniently minimizing that Packard produced 55,000 Merlin engines under license more than Rolls-Royce built in Britain, and that every other component, from the airframe to the .50 caliber Browning machine guns, was American-designed and American-built. Packard Motor Company production records, 1945, November 8, 1944. Metz, France. The U.S. Third Army is grinding through fortifications that have resisted siege for centuries. Patton's armor is stalled, his infantry taking casualties in brutal street fighting. Then the M26 Pershing arrives, 75 tons of American steel, mounting a 90mm gun capable of penetrating 180mm of armor at 1,000 yards, enough to kill any German tank in service, including the vaunted Tiger to Aberdeen Proving Ground penetration tests, 1944. Only 20 Pershings reach Europe before WWII, but their psychological impact is immense. German tank crews, accustomed to frontal invulnerability, report dramatized composite, a terror weapon, fast as a Sherman but armed like our heaviest assault guns. The Pershing's stabilized gun sight, designed by Westinghouse, allows accurate fire while moving, a capability German tanks will not achieve until post-war designs. Ordnance Department Technical Manual TM9731B, 1945. Soviet observers at the Battle of Cologne in March 1945 watch a single Pershing destroy a Panther and a Tiger at close range. Note every detail, and within 2 years will produce the T-54A design, clearly influenced by American armor, geometry, and gun stabilization principles. Soviet Tank Design Bureau reports. Declassified 1992. The Pershing's contribution to ending the war will be footnoted. The T-54 will be hailed as Soviet genius. And then there was the proximity fuse, the weapon that changed everything. Developed by Section T of the National Defense Research Committee and refined by engineers at Raytheon, General Electric, and Sylvania, the VT fuse was a vacuum tube radio receiver, small enough to fit inside an artillery shell, rugged enough to withstand 20,000 GI forces at firing, and smart enough to detonate when reflected radio waves indicated proximity to a target. Applied Physics Laboratory Technical Report, 1945. When deployed against V-1 flying bombs over Britain in 1944, VT-2 shells achieved kill rates of 79%, compared to 24% for conventional timed fuses. Anti-Aircraft Command Report, August 1944. At the Battle of the Bulge, American artillery battalions equipped with VT rounds shredded German infantry assaults that had previously been unstoppable, turning ardent snowfields into killing grounds. A single 105mm howitzer battery could now achieve the defensive firepower of an entire WWII World War I artillery regiment. U.S. Army Artillery School analysis, 1945. The fuse was so secret that it was initially banned from use over land only, over water, where duds could not be recovered by the enemy. When the restriction lifted in December 1944, it broke the back of Hitler's last offensive. British and Canadian forces used American VTI-fused ammunition extensively in the final campaigns of 1945, yet post-war histories would describe Allied artillery superiority as if all Allied nations contributed equally to the technological breakthrough that made it possible. The theft was not violent. It was bureaucratic, linguistic, passive. A British report would describe Allied radar. A Soviet general would praise anti-fascist industrial cooperation. An American veteran would return home, never knowing his -300 Seychelles rupees radio would be studied, copied, and rebranded in a dozen nations. The weapons that won the war were being quietly naturalized. Their American birth certificates filed away in archives no one would read for generations. The strategic impact of American technological dominance cannot be measured in battles alone. It must be measured in the cascading collapse of Axis morale, the reshaping of Allied doctrine, and the silent desperation that crept into German and Japanese war planning as 1944 became 1945. By the final year of the war, Axis commanders were no longer fighting to win. They were fighting to delay the inevitable, knowing that American industrial and technological supremacy had rendered victory mathematically impossible. German Field Marshal Gerd von Rundstedt, captured in May 1945, told American interrogators that the Wehrmacht's greatest miscalculation was not underestimating Soviet manpower or British resolve, but failing to comprehend the speed at which American industry could translate scientific innovation into frontline dominance. U.S. Strategic Bombing Survey, Interrogation Report No. 245, June 1945. German logisticians had calculated that American tank production would peak at 1,500 units per month. By mid-1943, the American factories were producing 2,400 tanks per month, while simultaneously building 8,000 aircraft, 7,500 artillery pieces, and 120 million rounds of ammunition. War Production Board Statistical Summary, 1943. The disparity was so extreme that German intelligence officers refused to believe their own reconnaissance reports, assuming the numbers were Allied disinformation dramatized composite. No nation could sustain such output without total economic collapse. But America was not collapsing. It was accelerating. The psychological toll on Axis forces was devastating. Japanese naval officers, surveying the wreckage of their carrier fleet after the Battle of the Philippine Sea in June 1944, understood that American shipyards were now launching Essex-class aircraft carriers faster than Japan could train pilots to oppose them. Japanese Naval Staff College Post-War Analysis, 1946. American radar-directed fighter interception had achieved kill ratios of 19:1 during the Great Marianas Turkey Shoot, a slaughter so one-sided that Japanese aviators called it the end of naval aviation. U.S. Navy Action Report, Task Force 58, June 1944. Every Japanese pilot shot down represented 18 months of training that could never be replaced. Every American pilot lost was replaced within weeks by the vast training infrastructure of the Arno scheme, which graduated 193,440 pilots. During the war, more than all other Allied and Axis nations combined, U.S. Army Air Forces Statistical Digest, 1945. The mathematics of attrition had become the mathematics of annihilation. On the ground, American logistics rewrote the rules of sustained offensive operations. The Red Ball Express, a trucking network that moved 12,500 tons of supplies per day from Normandy beaches to Patton's advancing armor in August 1940. 4 operated on a scale that left British and Soviet observers stunned. Transportation Corps Historical Report, 1945. The trucks were American-built GMC KW Dusseldorfs, 562,750 of which were produced during the war, making it the most manufactured military vehicle in history. General Motors production records, 1946. Soviet forces received 409,500 of these trucks under Lend-Lease, and Soviet Marshal Georgy Zhukov would later admit, authenticated, quote, "Without American machines, we would have lost the war." Zhukov, Memoirs and Reflections, 1969. Yet Soviet histories published during the Cold War would downplay or entirely omit American contributions, crediting Soviet victory to ideological superiority and the genius of Stalin's leadership. The trucks that carried Soviet artillery to Berlin became invisible. The human cost of maintaining American technological superiority is often forgotten. Behind every -300 Sesha rupees radio was a signal corps maintenance technician who kept vacuum tubes functioning in sub-zero temperatures and tropical humidity. Behind every proximity fuse was a female assembly worker at a Crossley Corporation plant in Indiana, soldering circuits with such precision that rejection rates fell below 2% by 1944 war. Manpower, Commission, Report, Electronics Production, 1945. Behind every Liberty ship was a welder at Kaiser's shipyards in Richmond, California, where Henry Kaiser's revolutionary prefabrication techniques reduced construction time from 244 days to 42 days, making him the most important industrial innovator. Of the War U.S. Maritime Commission case study, Kaiser Methods, 1943. These workers, disproportionately women, African Americans, and rural Americans, who had never seen an assembly line, sustained the material advantage that made Allied victory possible. Their contribution would be compressed into generic phrases, like the home front and wartime production, stripped of specificity, drained of credit. The theft became institutional in the post-war era. NATO standardization agreements quietly adopted American military standards for everything from radio frequencies to ammunition calibers, but the documentation credited them as Allied standards, developed through multinational cooperation. NATO Standardization Agreement Index, 1949 to 1955. The Jeep, perhaps the most iconic military vehicle of the 20th century, was copied by nearly every nation on Earth. The Soviet GAZ-67, the British Land Rover, the French Hotchkiss, M201, derivatives of Willys Overland's design, yet described in their respective national histories as indigenous innovations. Society of Automotive Engineers, Military Vehicle Evolution Study, 1978. The Cavity Magnetron, whose mass production by American firms enabled shipboard and airborne radar systems that won the Battle of the Atlantic, was enshrined in British science museums as a purely British invention, with American contributions relegated to fine print on technical plaques that museum visitors never read. By the 1960s, the narrative had hardened into conventional wisdom. British histories emphasized Bletchley Park, code-breaking, and radar as the twin pillars of victory, minimizing that American kryptonihilists at Arlington Hall broke Japanese codes independently, and that American radar production exceeded British output by a factor of 20. National Security Agency Historical Review, declassified, 1996. Soviet histories credited Lend-Lease as minor assistance, representing less than 4% of Soviet war production, a statistical manipulation that ignored that the 4% included 15 million pairs of boots, 1.75 million tons of food, and 13,000 locomotives, mobility and logistics backbone without which Soviet offensives would have stalled U.S. Department of State. Lend-Lease Final Settlement Report, 1972. French histories celebrated the liberation of Paris as a triumph of the French resistance, with photographs of General Leclerc entering the city aboard American-built M4 Sherman tanks that were cropped or captioned to obscure their origin. The legacy of this erasure extends into modern warfare. American GPS satellites guide munitions for dozens nations that contribute nothing to the system's maintenance but describe their precision strike capabilities as indigenous achievements. American aerial refueling technology, developed by Boeing in the 1950s based on wartime innovations, enables air forces worldwide to project power across oceans, yet is treated as a commodity rather than a continuing American contribution to Allied military capability. Air Force Historical Research Agency, Tanker Development Study, 2003, the revolution in military affairs that defined late 20th century war for network-centric operations, precision guidance, satellite communications, stealth technology emerged almost entirely from American research institutions and defense contractors. Yet multinational coalitions describe their capabilities as allied interoperability rather than dependence on American technological infrastructure. The lesson of World War II is not that America won the war alone. Soviet blood, British intelligence, and the resistance movements of occupied Europe were all essential. But the technological and industrial foundation that made Allied victory possible, the radies, the coordinated armies, the proximity fuses that shattered German formations, the logistics networks that sustained offensives across two oceans, the production lines that buried the Axis in steel, these were overwhelmingly American achievements, built by American engineers, funded by American taxpayers, and operated by American workers who expected no reward beyond victory. They deserved remembrance. They received obscurity. In the end, the theft was perfect because it was voluntary. America gave away the credit, along with the weapons, too focused on winning the war to worry about who would write its history. 80 years later, the evidence remains in archives and technical manuals, waiting for anyone curious enough to look. The weapons spoke once in fire and thunder. Now they speak only in footnotes, whispering a truth the world has chosen to forget. That American innovation turned the tide of the most destructive war in human history. And the only thing more impressive than that achievement was the world's collective ability to pretend it never happened.